We mainly work with 4 people that assemble our products, electricians, mechanical engineers, and with 40 subcontractors that all manufacture their parts on our assignment and our specifications.
The principle of an air fluidized bead bed works as follows. By blowing well-diffused air into a basin filled with very fine glass beads, a dry fluid is created that looks much like boiling water. The basin is covered with a generously proportioned filter sheet with a hospital sheet on top. A patient who is treated on this special mattress will float, experiencing virtually no pressure on the skin. The diffused airflow has a low intensity and a controlled temperature and relative humidity. These conditions provide a fluidizing mass with a constant temperature, which has a drying effect on the wounds. Exudates, mixed with bacteria from the patient's wounds, are absorbed by the hospital sheet and filter sheet and sink into the glass beads. The filtered airflow, combined with the low humidity, rapidly reduces the growth of the bacteria. The exudates with the deactivated bacteria and other body excretions are captured by the glass beads. These, in turn, will be dried by the airflow, forming a dehydrated high-alkaline clump of matter. The glass beads are cleaned on a regular basis by removing the dried clumps with a sieve.
When you see the principle, it looks like boiling milk, but if you touch...
Despite its weight, the system can easily be moved by the nursing staff. As the bulk of the control unit can be stored under the bed, only a limited amount of space is needed for the system. After installation, the control unit is connected to the bed. Then the power supply and temperature sensor plugs are connected, and the air supply tube is fastened. The control unit is pushed next to the bed and secured against rolling back. Finally, the hand and foot switches are plugged in, and the power supply is connected. After activation of the main switch, the airflow can be started or stopped with either the hand switch or the foot switch. The bubbling effect of the glass beads should be evenly distributed over the bed. If this is not the case, the frame of the basin should be leveled by the adjusting bolts. The sieve is put on the glass beads. It will automatically sink to the bottom of the bed after activation of the airflow. Before the fluidization is started, the filter sheet is put in place. The edge with Velcro is pressed into the groove to prevent leakage of the glass beads. Lastly, a rubber rim is placed over the edge of the bed and the filter sheet to protect against sharp edges. From the control panel, the temperature of the bed can be precisely adjusted, allowing any desired temperature between 26 and 38 degrees Celsius to be selected. The system is secured with an alarm which warns if the bed temperature differs more than 2 degrees from the set temperature, or if the bed temperature increases to more than 40 degrees Celsius. The intensity of the airflow can be infinitely adjusted by means of a potentiometer. The mattress will feel harder when the airflow is reduced. The pressure gauge displays the airflow intensity. In order to mobilize patients and to prevent contraction of muscles, the pulsation system can be used. By alternately blowing more and less air into the bed, the muscles are activated and the body is fixed in the glass beads. The duration of the cycles can be adjusted, and there will remain enough airflow to control the temperature of the bed. In case of heart attack or other emergency, rapid action is needed. The CPR button immediately deactivates all functions, and the airflow is stopped. The system contains a number of important ergonomic aspects. By raising or lowering the bed, nursing staff with differing heights can easily work with the patient. Also, the fluidization principle simplifies the repositioning, even of patients having excessive body weight. Patients can also sit in the bed. For this purpose, a backrest and traction support are available. By pulling the patient into a sitting position, the backrest can be placed behind the patient. By reducing the intensity of the airflow, a tendency to slide is prevented. After conclusion of the treatment period, the system must be decontaminated. Therefore, an integrated and automated heating device has been developed. With a special key, the heating cycle is started to kill all bacteria. The temperature of the beads is raised to more than 90 degrees centigrade and maintained for 2 hours. Thanks to this technology, cross-infection can be prevented without the need to transport the system for decontamination. After cleaning the exterior, replacing the sieve and installing a new filter sheet, the bed is ready for a new patient. The control unit can also be placed and operated at a distance. In this case, a tube of maximum 6 meters in length is connected between the bed and the control unit. The separate control unit offers great advantage in case of an interruption. The patient can stay on the bed while only the faulty control unit is replaced. The unit can be placed on a table to enable easy